2, 1, go.
Cheers, everyone, and welcome to this month's Astronomy on Tap. For those of you who join us for the first time, I will quickly say how this event will go. I will be soon joined by our speaker of tonight and a member of our team, and we will talk for a few minutes about some astronomy-related news. After that, our speaker will give his talk, his or her talk, during which you can ask all of your questions on all of our social media, so YouTube, Facebook, Twitter, everything really. And after the talk, I will ask your questions to our speaker, and then we can all move to the Zoom pub to have an amazing pub quiz during which you can ask all of us questions, but also speak directly with the speaker. So without further ado, our speaker of tonight is a member of our team, is Kateryna Frantseva. Hey.
Hello, Laurent.
Hey, hey. So used to being on the stream. And who is joining us for the news of tonight is our another member that you might have seen the work on Facebook because she's working with Katja on our social media, is Valentina Perano. Hey, Valentina.
Hello.
How are you doing?
I'm fine.
Yes. And so, yeah, we can directly jump into tonight's news. And so, who says July says, of course, the moon landing. That was on the 21st of July, 1969 by America. They were the first on the moon. But before mentioning the success of America, I want to say the few firsts that happened before was the first hard landing on the moon. Hard landing meaning that they crashed the spacecraft on the moon was actually by the Soviet Union in '59. And then the first man in space was also the Soviet Union in '61. And then the first soft landing, meaning just gently landing on the moon, was in '66.
Your phone stuff.
JQ, not muted.
I think our technical team is not muted, and
What?
so probably everybody
I hear them.
the chatting of our technical team.
No, you can just hear us. No one else can hear.
So yeah, it was a lot of firsts for the Soviet Union, which we don't speak enough of because it was completely removed by the first man on the moon by by the American during the Apollo 11 mission. And the goal of the mission, of course, was just to win the space race, so to be the first to put a man on the moon and bring it. Of course, they also justify it by saying we want to bring a sample from the moon. And after that, 12 men have been on the moon between '69 and '72. One of them, very American, just smacked 2 golf balls on the surface of the moon. Just for just for the fun of it. I guess it's America. You don't have to ask about
Okay.
it. You just do it.
I didn't know that.
I've seen recently that they've checked where the ball landed. So they're still looking into that. But yeah, we have been in we haven't been since 1972 actually on the moon after these 12 men. And this is because, so America, it's because for political reasons, because the president keeps changing and keeps changing also the budget and the missions and the funding for the different space missions of the NASA. So nobody managed to go back again. And the last thing is because the next time we go back, we have to do it for a new reason, because getting sample from the moon is very easy to do. And the new reason would be to actually settle on the moon. So to make kind of a human settlement, and it's really hard because of all the dust. But it might happen someday. What do you think?
Well, I think it will happen, which I guess we're gonna talk about it a little bit later, but there is like a lot of money being put in the space exploration. I mean, I don't know, maybe we could like prove people wrong, people that think that we never got to the moon. Yeah. And they show like, guys, it's here. We were here before. That would be nice.
if at some point we manage to bring citizens to the moon,
Yeah.
maybe. But I guess it's in a long time, because now it's just
Yeah,
not
I would think so.
effective.
Yeah, I think that maybe not. Well, one option is like to make a settlement on the moon, and the other option would be to have some kind of a, well, say, let's call it a gas station at the moon. So basically, just a place where you get a bit of more fuel for further travel. Also, for example, if you want to mine something, then you can use moon as a stop by place, either to get fuel or to store the resources that you collect. So I think that in the future, that's one of the, that's possible.
Yeah,
I think it will be like a stop station, like a gas station where like, people can get resources and continue exploring. That would
Yeah,
be-
stop on the moon, get your tweaks, and keep flying further.
someday it will be that easy, I guess. Yeah. But this day might be sooner than we expect, but not from the public companies or public institutions, but from the private one, because recently there's been this space race, this billionaire space race. Apparently, it's a new thing where Richard Branson from the Virgin Group, Jeff Bezos from Amazon, and Elon Musk from Tesla, PayPal, all of that, they've all been starting to invest into space tourism. And yeah, it's actually, they talk like it's just around the corner, with Richard Branson saying that by 2022, so by next year, he already wants to bring some tourists at the age of space, for tickets of like $200,000. And apparently he already has 600 reservations.
How much? It's fine. We can manage to get
And
2,000.
the point is to bring the tickets down to $14,000, so very affordable. I mean, really
Yeah.
not. Blue Origins also have the same, and apparently there was also an auction, and the ticket went for the first flight of Blue Origin went for $28 million. That was a good auction. And SpaceX, as we know, is also or has already flew some crew member to the ISS, so they're already on their way there. And for the missions, so I actually just read that Richard Branson went on his mission. He wanted to try it himself before giving it to the people. And the thing is, it's a 1.5 hour flight with a few minutes of weightlessness. And the interesting thing is, it goes at the edge of space, and as Jake actually mentioned to us, our technical crew, for the edge of space is actually technically at 100 kilometers from the Earth, but for America, it's actually at 80 kilometers from the Earth. So he went there, but I've read some people saying, nah, he didn't really go, so that doesn't really count. But maybe that's the future.
It went for American people.
Yeah, you went. But
Yeah,
so,
the
are you
person
following
who was saying-
this space race?
I know, I wanted to say that the person who was saying that it's not really space and your spaceship is not really a spaceship, but just an airplane, it was Jeff Bezos.
Yeah, I've read. I wasn't sure. I just read. But I was like,
That's better, you know.
yeah, this is really.
We'll find out on the 20th.
This is really this petty war. Billionaires like, I'm gonna go first, and I've read that other people are interested also in space tourism. But that might be the future, and it might be much closer than we think. So yeah.
Do you think, for example, in the future we might have space tourism, and all these flights are definitely very good for the technology, for space exploration, but I still think that for quite a long time this will be just some fancy activity for extremely rich people.
Yeah, that's what
I was reading today about this to be informed, and actually Virgin, like the one from Richard Branson, is the only one that is open for like people to invest in.
Yeah,
all the others are private companies. So a lot of people say that this is just for the ultra rich to enjoy, like space and all the access we're gonna have now is just for people that have money. It's not gonna get to us normal people.
The best thing, but I don't think it's gonna be, but the best thing is if they would actually use the space tourism to just make more money, but at the end to help us, you know, explore.
Reinvested in science.
Yeah, exactly.
That would be great, but I don't think that's what they are planning to do with the money that they're gonna make with this.
No, I totally believe that Jeff Bezos does that for, you know, humanity.
Yeah, sure. That's how he manages Amazon as well, with a lot of humanity.
Exactly, yeah. We've read a lot about that. But we can move on to maybe some less dystopian news. And this is actually something that happened in May 15th, but that I missed, was that the Chinese rover, Zhurong, so named after the god of fire in Chinese, made it to Mars in its first try. And so something that took the NASA decades to do, which is to orbit, land, and rover on Mars, meaning, you know, having your little rover going around. They managed to do that on the first try. I'm also guessing that they're using all the experience and all the knowledge from NASA from the last decades. And the program for 3 months is to probe the environment and to search for ice water. But also what I'm guessing is they're like just really trying to get up to date with this space program that is now becoming more and more important. And this is actually just the last accomplishment in a long series for China, because they've only started to their first crewed space flight was in 2003, so that wasn't that long ago, and they're already sending rover to Mars. And last year they brought rock from the moon, and that didn't happen since the 70s. And more importantly, what I didn't know is that they launched the first stage of the next space station. So they also want to have a space station. And so China is actually getting very serious in this race to space. So yeah, what's your opinion on that? Do you think the future of space is in China?
I mean, I don't know. Because with all that we were talking about this, all these millionaires investing all this money in space, I don't know. It's before it was just like scientific community pushing forward like missions to get to space and put like satellites to observe space better and better. But now that there is some money interest in it, I don't know. They will have to compete also with all the billionaires. But I think, I mean, I study X-rays in neutron star and black holes, and the Chinese are doing a lot with that as well. So I think they,
on the science part, they're getting,
yeah, they're moving forward their science for sure.
That's great. I mean, the real thing is the speed at which they're progressing is insane. Like in 20 years, they're already there. And so yeah, the space billionaires are there for the money, but at least China is doing science, which is quite good. And on the other hand, America is doing a bit down because there was a problem with Hubble that we talked about in quite some detail 2 months ago, because on June 13th this year, the computer controlling the instrument malfunctioned. And so Hubble has been in safe mode, so nothing is really destroyed. The instruments are still good, but the telescope is unable to observe, and they're still not sure why. They thought it was a problem with memory, but apparently switching to other memory, because they have a lot of backups in Hubble, switching to another memory cartridge doesn't really solve the problem. And so now they're trying to do new tests, and what they're gonna do is they're gonna switch to the other computer, because they have two computers. They have the normal one, and they have a whole backup one, an entire double system. But this is very tricky to do, and so they're still doing tests for it. But in the meantime, no amazing pictures from Hubble. That's it's quite sad. So does it?
Sorry, I thought. What I read today is that they had finished the tests and that they were like successful.
Mm-hmm.
Yeah, I checked the NASA website and they give you a timeline of everything.
Mm-hmm.
And apparently the tests were successful. So next week they should switch on the backup computer and hopefully things will work out, or maybe they will find out exactly what is wrong and fix it. I have no idea, but they say the test that they did for like a week, they work out.
Yeah, that's good. And yeah, to say that Hubble was supposed to work for 15 years and is now working for 30 years, so it's still quite an achievement. And now it's going to be able to pass the torch to the next generation of space telescopes, which we've all been waiting for way too long now.
Yes.
So that's great. Okay. Then thank you, Valentina, for
that's the news.
For your amazing intervention.
Thank you for having me. Yeah.
And we will see you during the pub quiz.
Yes, of course. I'll be there. See you later, guys.
Yeah.
Bye-bye.
Join the pub, everyone.
And now, Katja, you can tell us all about the exoasteroid.
Okay. And I'll try to share my screen.
Yeah.
And
yes, but
okay.
Okay.
Good to know.
The floor is yours.
Yeah, thank you. So good evening, everybody. My name is Kateryna Frantseva, and I'm a researcher and lecturer at the University of Groningen. And today's edition, oops. Why no? Okay, just a second. Can you hear me? Yeah, I guess you can hear me, right?
Yeah, we can hear you, but the screen is stuck at your...
Yeah, so I will just... I will share it again.
Just click on it. If it's a Mac, click on it.
It was
and then you can do it.
stuck, so I now will share it again. Okay. Let's hope that now it's okay. Yes.
Yes, it's working.
Okay. So today's edition of this of the Astronomy on Tap Groningen is dedicated to the Asteroid Day. And Asteroid Day is held every year on 30th of June to mark the date of the Earth's largest asteroid impact in recorded history, which happened at the beginning of 20th century when an asteroid exploded near the Tunguska River in Siberia. Asteroid Day was founded to educate public about the importance of asteroids in our own history, for example, like Tunguska event, and also about the role of asteroids and which role they play in our own solar system. Fun fact, well, not fun fact, but just interesting fact, that in 2016, the United Nations declared Asteroid Day to be a global day of education to raise awareness and promote knowledge in the general public about asteroids. One of the co-founders of the Asteroid Day is the astrophysicist and famous musician, Dr. Brian May, of the rock group Queen. And that's why no wonder that the anthem of the Asteroid Day, and yes, Asteroid Day has an anthem. So the anthem is "We Will Rock You." So if you wonder why actually we need to raise awareness about asteroids, well, it's because asteroids, despite providing a lot of information about origin and also evolution of our own solar system, can be potential danger to our planet. Therefore, it is important to detect as many asteroids as possible and develop asteroid deflection techniques. And so every year, Asteroid Day has a different topic. So basically to cover as many asteroid topics as possible, and also to tell people about different things related to asteroids. And so this year Asteroid Day is celebrating the 25th launch anniversary of NASA's Near Shoemaker spacecraft. This spacecraft was the first spacecraft to successfully orbit an asteroid and also land on an asteroid. And another event that this year's Asteroid Day is celebrating is the upcoming launch of 3 asteroid missions. And I think it's impressive, actually 3 upcoming asteroid missions to fly, to be launched in 2021. I think that, so it's 2021, potentially 2022, depends on the launch window, etc. But I think it's really impressive that within a year, we will have 3 more asteroid missions. And so these 3 asteroid missions are Lucy, the mission that will visit 7 asteroids. The other mission is, oh, sorry, too far. The other mission that is called NEAR Scout. NEAR stands for Near Earth Asteroid. And NEAR Scout is also a very interesting mission because it's a tiny spacecraft, also known as CubeSat. And this satellite is supposed to map an asteroid and also demonstrate several technological firsts. So for example, this will be the very first CubeSat ever to reach an asteroid. Also, in what is very nice about this mission, that CubeSats are, let's say, quite cheap. So if the satellite will be able to, to successfully map an asteroid, then this will mean that we can start using CubeSats to study more and more asteroids. And the third mission to fly soon is called DART, and this will be the first world mission to test an asteroid deflection technique. Also super cool and important. So now a little bit in general about asteroids. So what are asteroids? Well, asteroids are shattered remnants of planetesimals that never managed to grow large enough and to become planets. So they just, well, they stayed small. And they are orbiting around the sun, just like Earth and other planets. And the very first asteroid, named Ceres, was discovered on 1st of January, 1801 by Giuseppe Piazzi. And Giuseppe thought that it was a planet. But a couple of asteroid discoveries later, the astronomer Sir William Herschel proposed the term asteroid, which in Greek means star-like. So he proposed to call all the newly discovered objects, to call them asteroids. And the reason for the name, for the star-like term, was that with the equipment at the time, so it's 19th century, the equipment at the time, asteroids, they when you look at them, they would just look like points of light, and they would show basically no planetary disk, like for example if you try to look at Mars, but still the asteroids would look different from stars because they would move a lot. And so that's why the term stayed with us, and we call them asteroids nowadays. Asteroids come in different sizes and shapes. For example, Ceres, the largest one that you can see in the top left corner. Yeah, top left. The Ceres, the largest one, has a diameter of about 1 France. That is about 1,000 kilometers. The rest of asteroids, as you can see here on the pictures, they have more irregular shapes, while their sizes vary from hundreds of meters to hundreds of kilometers. All the asteroids that you see here on this slide, all these pictures were taken by spacecrafts in the past. And for example, in the very center, there is asteroid Eros, and I will try, yeah, it's here. And I think, well, I hope you see my mouse. So the asteroid Eros in the very center of the slide, that's the asteroid that was orbited and landed on by the mission Near Shoemaker, the one that we celebrate 25th launch anniversary this year. And the fun fact about asteroid Eros, well, Eros is named after the god of love, right? And the spacecraft that was studying it near Shoemaker successfully entered orbit of Eros in year 2000 on Valentine's Day. So it was a very romantic rendezvous on Valentine's Day of the spacecraft and the god of love. Okay, so starting with the discovery of the very first asteroid in 1801, astronomers have been discovering more and more asteroids in our solar system. But what about outside of our solar system? What about around other stars? Well, since 1995, after the discovery of the very first exoplanet around the solar type star, it has become well known that our own sun is not the only star to host planets. And by the way, this discovery received the 2000 Nobel Prize in Physics. And so the very first exoplanet was discovered with the radial velocity technique. And the technique is based on the fact that the star doesn't, the star doesn't stay stationary when it's orbited by a planet. So the small movement of the star can be detected. And in this way, we can find out if there is an exoplanet around the star or not. And only 10 years, less than 10 years after the discovery of the very first exoplanet, we discovered asteroid belts in other planetary systems. And seeing that planets and asteroids, but also comets, that they exist not only around our own sun, but also around other stars, gives us a hint that interaction between planets and asteroids should be very similar as in our solar system, also around other stars in exoplanetary systems. And so which kind of interaction I'm talking about? Well, in our solar system, asteroids, they impact with planets from time to time, also with Earth. And we know that in the past, when our solar system was younger, then this bombardment of asteroids was much stronger. And through this bombardment, any material that is present in the asteroid would be delivered to the planet, right? So for example, there are indications that appreciable amounts of water and organic compounds were delivered to Earth at the early stages of the formation of our solar system. And so, for example, if various materials can be delivered from asteroids to planets in our solar system, then exactly the same thing should be happening around other stars, right? And this brings me to a very, very interesting exoplanetary system that I would like to talk about tonight. And that's a system that is called HR 8799. Well, the name comes from the name of the star. So the name of the star is HR 8799. And then there are also planets around the star. And the planets, so there are 4 planets, and they were discovered through direct imaging. And so the direct imaging works in a way that when a planet is just so huge and bright that it's possible to take a picture of it. So here we have a picture of the exoplanetary system. So let's have a closer look at the system. Well, it has 4 planets, as I already said, and each of the 4 planets is as massive as 10 Jupiters. So imagine you have 1 Jupiter that is the largest planet in our system, and then you put 10 Jupiters together, and you get one of the planets in the system, HR 8799. That's quite a lot, right? And also, the animation that you see, it's the animation that is composed of images taken over a course of approximately 7 years. And so you can see how planets move. So in the very center, like a small yellow star, that's the star. The light from the star is blocked. And then around you see 4 blobs that are moving. And so these 4 blobs are exoplanets. And I just find it extremely fascinating to see a video like that, where you can see how planets move around a star that is, well, not the sun, that is somewhere far away, and you see how they move. I don't know, I really like it. Another interesting thing about the system is that structurally, it is similar to our own solar system. So here you see two schematic pictures of the system HR and of the solar system. And so you see them face on. And the distances are in astronomical units, where one astronomical unit is distance between Earth and Sun. So first of all, the system HR has 4 large planets, and they resemble Jupiter, Saturn, Uranus, and Neptune in our own solar system. And then another interesting thing, and the planets are indicated on these pictures as gray circles. In the very center of each picture, that's the star, so Sun in the solar system, and HR 8799 in the exoplanetary system. And then we see that there are also 2 rings. So there is red ring inside of each picture, and there is blue ring in the solar system, and like a blue surrounding around the HR 8799. These are 2 asteroid belts. So the inner one is the called warm asteroid belt, and warm because, it's warmer than the cold one, and the cold one is outside, and warmer because, it's closer to the star, so it's warm. And in the solar system, we also have the warm red belt. That is the main asteroid belt located between Mars and Jupiter. And then also we have a belt outside that is called Kuiper belt. And so the structure of the two systems is very similar. In solar system, inside of the warm belt, we know that there are more planets like Earth, but also Mercury and Venus and Mars. And in system HR 8799, we still don't know if there are any planets inside of this warm belt, just because, our current facilities are not sensitive enough to discover if there are any planets. But of course, potentially they may exist there. And so why I'm talking about the system? Well, because as I said, we expect that interactions between asteroids and planets in our solar system and also around other stars should be very similar. So we were very curious, what about the system HR 8799? It has 4 planets and it has 2 belts of asteroids. And so what is happening, what is the interaction between planets and asteroids? Do asteroids impact on the planets? If they do, then do they bring any material, how much, which kind of material? So we decided to research these questions, and we built a computer model of gravitational interactions. So basically how planets orbit around the star, how also asteroids orbit around the star, how they interact with each other. And and we wanted to find out if there are any collisions and what are the results of these collisions. And so what we found is that asteroids from both belts, from the inner warm one, from the outer cold one, they impact with all 4 planets. And then, of course, through these impacts, they deliver different materials. And so here I have two groups of materials. On the left, you have minerals and metals. And on the right, you have water and carbon-bearing various materials, also known as organic materials. That is, for some astronomers, it's basically anything that contains carbon. And so we calculated how much of these different materials asteroids bring to planets. And so for the minerals and metals, we found that it's 0.1% of Earth mass. So 1% and then 0.1 of the Earth's mass. And for the water and different organic compounds, it's half of that. And you might think, wow, 100% of the Earth's mass, that's maybe a lot, but still doesn't sound like a lot, right? So I decided to compare it to the masses of how much material will be brought by asteroids to those exoplanets in terms of sperm whales. So 1/10 of Earth's mass, it will be 1 and then 0, 0, and like this 17 times, so 17 zeros. And I actually had to, honestly, I had to Google how to pronounce the number. So it's 100 quadrillion sperm whales. So 100 quadrillion sperm whales of minerals and metals asteroids will deliver to exoplanets in the system HR 8799. Well, that's quite a lot. But now that we know how much of materials will be delivered, the question is, can we actually, well, this still comes from theory, right? We made a model, we calculated, but then can we somehow observe it? Can we find out if that's happening, or yeah, so how can we check our model? And here comes a couple of things. So first of all, that's why I was showing you two different types of materials. So you have minerals and metals, and then you have water and organic compounds. So water and organic compounds, we wouldn't be able to detect, simply because the planets, the exoplanets in this system, they're expected to be composed of a lot of water and organic compounds. So if we look at those exoplanets of the atmospheres of those exoplanets, and we look for water and organic compounds, and if we find them, then we cannot say that they were delivered by asteroids, simply because the planets were already supposed to be built like that. But if we look at those exoplanets and we find excess amount of minerals and metals, then we can say, yes, this amount of material can be actually, can indicate that this material was brought by asteroids. And so how can we do it? Can we do it from the ground with ground-based telescopes? Well, unfortunately, it's a little bit hard, because the range of wavelengths where we would look for the spectral features of minerals and metals, it's partially blocked by our own atmosphere. And so that's why the great solution is the space telescopes. And here comes JWST. So JWST is the James Webb Space Telescope, is the next huge space telescope that everybody is waiting for, as Laurent said earlier, for a very, very long time. But with the help of James Webb Space Telescope, we will be able to search for mineral and metals in the atmospheres of the exoplanets in the system HR 8799. And that's all what I wanted to tell you today. Thank you very much. And if you have any questions, I will be very happy to answer them.
Thank you, Katja. There is a few questions. I just wanted to say that I really like the slides with the dinosaurs and the, let's say, the economy with the comet. And I'm not the only one, because one of the questions starts with awesome slides with the dinosaurs. Is it now certain that an asteroid made them go extinct? I've heard that a supervolcano was also possible.
About that? So I don't know about supervolcano, but one article that I read recently is that there has been a new discovery of dinosaur fossils that indicates that they started to get extinct. I think almost like 10 million years before the asteroid impact, and that one of the indications was that they started to get extinct because of the climate change. So
yeah. Not from the asteroid then.
But I know that I think in the article they were trying to say that probably the process of extinction was started by climate change, but then that the asteroid was like a last last nail in the coffin. Is it an English way of saying?
Yeah.
Okay, yeah.
It really happens.
Yeah.
Second question: is there a maximum and a minimum size for asteroids?
Yeah. let's say yes. So for example, Ceres, that used to be the largest asteroid. It has the diameter of 1,000 kilometers. And Ceres nowadays is not considered an asteroid, but considered a dwarf planet because it's actually large enough to have spherical shape. So anything below diameter 1,000 kilometers should be an asteroid. And then for the minimum size, well, in different literature, you will find that starting from 10 meters or starting from 1 meter.
Can we detect those?
1 meter, 10 meters, I don't think so. Well, yeah, I think tens of meters for sure. Yeah, but like a couple of meters, yeah, that one I'm not sure.
That might be too small. Maybe.
Yeah, it might be too small. I mean, also, yeah, because they're tiny and also they have low albedos, so that the amount of light that they reflect is very, very low.
So they're both small and not very shiny.
Yeah, so if you have like an ice ball, it will reflect almost 100% of the light, right? And asteroids are usually dark. Well, okay, some of them, but yeah.
How common is it to find exoplanets in other solar systems?
So every star should have on average 1.7 planets. I think that was the result of the Kepler mission, the one that was detecting exoplanets.
It's very common.
Yeah.
Now, I hope you can answer this question. What would you recommend to prevent a big near-Earth asteroid from hitting the Earth and causing a lot of damage? Please, Katja.
So I know that there were quite some ideas of what to do about it once we find out that an asteroid is approaching us. And so one option was to paint one side of an asteroid in white or in black to change its albedo. So then because of the interaction with the solar radiation, then the asteroid will be slightly pushed in a certain direction, and so then it will miss the Earth. But I don't know about exact calculations, like how long it will take to push an asteroid with this technique. So maybe if there is an asteroid literally like next door, that's not going to work. And then the idea was, did you watch Armageddon?
Yes, but
but yeah, I think the option is, of course, to impact an asteroid with some missile, but not to try to destroy it, because if you try to destroy it, you just make it worse, because then you have one asteroid will turn into a lot of pieces that will be uncontrolled. So basically, instead of one impact, you will get a large scale problem, right? So the idea would be to slightly to impact it with some missile to basically move it a little bit, because but yeah, then we would need to calculate how much and in which direction, but the impact should work.
So we have paint or missile. Very good.
Yeah. I think there was also an idea like to use a big giant net. So you launch something like for not very large asteroids. So then you kind of like capture it in the net, and then you drag it a little bit in one direction.
And related to that, we have actually a question from YouTube that is, how good can we predict trajectories? Are collisions common in asteroid belts?
So how good we can predict trajectories? Well, I would say pretty good, because, for example, if you look now at the space missions that we had so far, the calculation of trajectories is just amazing. So, for example, the spacecraft that was sent to study comet 67P, the spacecraft was called Rosetta, and after its launch, I think that all the communication with the spacecraft was shut down for 10 years or about that. And then 10 years after, when they tried to connect with the spacecraft, they were able to find spacecraft exactly where they calculated and predicted. So the precision is quite good. The problem with asteroids is that we didn't discover all asteroids so far. So that's a factor of being unexpected. So sometimes if you have some, so for example, like, wait, how many years ago? Doesn't matter. Let's say 5 years ago, an asteroid impacted exploded over city Chelyabinsk in Russia. And we didn't know, and it was a small one, but we didn't know about it until I think it started to enter the Earth's atmosphere. Oh. And luckily it was not a large one, and also it exploded over the city. And so the largest damage that happened is just that some windows were shattered in the city. But imagine it's a little bit larger asteroid, and then the composition of this asteroid is slightly different, so it doesn't explode over the city, but it actually impacts, I don't know, collides with a building or something. Then
you can imagine that if it's a bit larger, maybe we can find it more easily. I'm just trying to reassure our viewer.
Yeah, sure. I mean, also now there are a lot of, with every year, there are more programs that are dedicated to dedicated to search for asteroids for smaller and smaller sizes, and also our sensitivity becomes better and better also with years, so we are able to detect smaller and smaller asteroids. So the future is bright, I would say. Don't be afraid. No need to buy canned soup yet.
Now about the system that you were talking about, HR 8799. How close is it? Did we find no asteroids in systems that are near because there are none, or is it just super lucky that we found them?
So the system is located, I think, 40 parsecs away. And if we didn't find closer, we might have found closer. So because for me, why I focused on the system, it was not because it's far or near, but it was because structurally it's so extremely similar to the solar system, because it has these 4 giant planets that are surrounded by 2 belts, exactly the same thing as in our solar system. So then that's why I wanted to study it, because also I think that it's one of the very few systems where we discovered 2 belts.
Like in our system.
Yeah. I think that, so the outer ones, the colder belts, they're more easy to detect. So we know quite a lot of those. But the system where you have 2, it's not so common yet.
We have a few more questions, but I think in the interest of time, maybe we will move on to the Zoom pub. So the person who has the questions, please join us in the Zoom pub, and you can directly talk with Katja, which is always a pleasure. And I guess we will see you in the pub quiz.
Yeah, okay, see you in the pub quiz.
When people can try to compete again and win the prize. So see you very soon.
Okay, yeah, and the link for the pub quiz will be under the YouTube video and under the Facebook Live, right?
Yes.
Okay.
And also on the
You can see it right now here somehow on the chair.
Yeah. So
and
.ol/ZoomPub.
ZoomPub.
Yes, stem.3spermwhales/
And just before finishing, somebody mentioned in the chat that Kurs Gesagt made a very good video about the dinosaurs and the asteroid belts.
Okay, cool. Then, yeah.
People are interested.
Okay, then see you soon.
Yes, very much.
Bye-bye.
Bye-bye, everyone. Jake, you can.
Yeah, I'm supposed to talk now and say, hey, please, as you see my t-shirt, the asteroids killing the dinosaurs, but please come and join us in the Zoom Pub. HTTP / whatever. stmm.oo/Zoom Pub. Come there, please join us. We'll see you shortly. Right now, we'll just go back to the background, then it'll stop going to be shared everywhere, and then just come there. It's easy.